Hey everyone, welcome to another video. I know it's been a while, but I just wanted to get my suggested solutions up for the 2024 Methods Exam 1 that just happened today. So yeah, let's get right into it. The first one, we're going to start off with the derivative like they usually do. So dy dx, this is going to be a mix of the product rule and the chain rule. So it's going to be the first function times the derivative of the second, which is going to be negative 3 sine of 3x, plus the second function, cos of 3x, times the derivative of the first one, which is e to the x. So we get negative 3 e to the x times sine of 3x plus e to the x cos of 3x. And that's going to be our final answer for that one. Okay, let's go to the next one. So f of x is a log function, and we're going to find f dash of 3. Now the good thing about a log base e function is that the derivative, it's not that difficult to compute. All it's going to be is the derivative of the inside, which is going to be 3x squared minus 3, divided by what's on the inside. Right, so then f dash of 3 is going to be 3 times 3 squared minus 3 over 3 cubed minus 3 times 3 plus 2. So this is going to be 3 times 9 minus 3 over 3 cubed, which is 27, minus 9 plus 2. This is going to be 27 minus 3 over 27 minus 7. That's going to be 24 over 20. Of course, we can simplify that. That's going to become 12 over 10. That's going to become 6 over 5. And that's going to be our final answer for this one, 6 over 5. Right? So not too bad. Okay, then we get into the simultaneous linear equations, right? So we have to determine the value of k for which this system of equations has no real solution. Now let's recap a little bit on when two systems of equations have no real solution. That's when they're parallel and their y-intercepts are different, right? You can see these two lines are never going to intersect. They have no real solution. So first, let's get both of these in y equals mx plus c form. So we get minus 2y equals minus 3kx plus k plus 4. Y is going to be 3 over 2 kx plus k plus 4 divided by negative 2. Then the other one is going to be ky equals minus k minus 4x minus k. And so y is going to be minus k minus 4 over k x minus 1. Now remember, we need their gradients to be the same. So we need minus k minus 4 over k, the gradient of this line right here, to be the same as 3 over 2k, which is the gradient of the other line. Now 3 over 2k, you can just write that as 3k over 2. And now cross multiplying, we're going to get 3k squared equals minus 2k minus 4. So 3k squared equals minus 2k plus 8. 3k squared plus 2k minus 8 is equal to 0. So 3k squared. And now we need two numbers that multiply to get negative 24 and add to get 2. Right, so we can do plus 6k minus 4k. Sorry, no, that's silly. Right? No, that's not silly. I'm the silly one. Sorry. So we get two numbers. We get 6k minus 4k minus 8. Right? Because 3 times minus 8 is negative 24. And now we can do 3k times 3k plus 2 minus 4. Oops, sorry. So factor out of 3k, going to get k plus 2. Factor out a minus 4 from here, going to get k plus 2. We're going to get 3k minus 4 times k plus 2 is equal to 0. K is equal to 4 over 3, or k is equal to negative 2. So to get the gradients to be the same, k has to equal 4 over 3, or k has to equal negative 2. Now remember, at the same time, we cannot have their y-intercepts being the same. So their y-intercepts have to be different. So the y-intercept of this line right here, k plus 4 on negative 2, cannot equal the y-intercept of this line right here, which is negative 1. So cross multiplying gives us k plus 4 cannot equal 2. So k cannot equal minus 2. You see k is equal to negative 2 here for one of them, but k cannot equal negative 2. So our only answer is going to be k is equal to 4 over 3. Okay, onto this. G of x is a truncus, right? So we're sketching a truncus here. And you have to label all asymptotes and equations with active intercept and whatnot. So the first thing we'll notice is that there's an asymptote, a vertical asymptote, at x equals negative 3, and a horizontal asymptote at y equals negative 2. So down here. Right, so now we know that the graph should look something like this. Right, but it's a matter of finding out the x and y intercepts. So first let's find out the y-intercept. We can do that by doing g of 0, which is going to be 1 over 3 squared minus 2. That's 1 over 9 minus 2. That's 1 over 9 minus 18 over 9. That's going to be minus 17 over 9. That's going to be right here, 0, comma minus 17 over 9. Now the trickier part is going to be solving for the x-intercepts. So we're going to let g of x equal 0. We get 1 over x plus 3 squared minus 2 is equal to 0. 1 over x plus 3 squared is equal to 2. And then cross multiplying, we're going to get 2 times x plus 3 squared is equal to 1. And let's just bring this around here. So we're going to get 2 times x squared plus 6x plus 9 is equal to 1. 2x squared plus 12x plus 18 is equal to 1. 2x squared plus 12x plus 17 is equal to 0. Okay. Now we need two numbers that multiply to positive 34, and the same two numbers have to add to 12, positive 12. So 2x squared, let's think about what these numbers can be. Right, you're going to see that there's not really any two numbers that we're getting that are going to be good for this. So what we can do is we can actually complete the square. Now, how do we do that? First, we have to find the coordinates of the turning point. So let's do that. The derivative here is going to be 4x plus 12. We're going to let that equal 0. X is going to equal minus 12 on 4, which is minus 3. Subbing that back in, we get 2 times minus 3 squared plus 12 times minus 3 plus 17. 2 times 9 plus 12 times negative 3 plus 17. So 18 minus 36 plus 17. Right, this is going to be 35 minus 36, that's negative 1. Okay, so the coordinates of the turning point are going to be negative 3, negative 1. So we can rewrite this equation as 2 times x plus 3 squared minus 1. And we wanted this to equal 0. So remember, turning point form, it has the coordinates of the turning point, and we just needed to take out this 2 at the front here. That's what we've done. So okay, let's try to solve this. Right, we're going to get 2 times x plus 3 squared is equal to 1. X plus 3 squared is equal to a half. X plus 3 is equal to plus or minus square root of a half. Now, plus or minus square root of a half is the same as plus or minus square root 2 on 2. And we get x is equal to minus 3 plus or minus root 2 on 2. Right? So we can put these in. So this is going to be minus 3 plus root 2 on 2, comma 0. And this one is going to be minus 3 minus root 2 on 2, comma 0. Okay, let's go on to the next one. Determine the area of the region bounded by the line x equals negative 2, the x-axis, the y-axis, and the graph of y equals g of x. Okay, so first off, we have x equals negative 2, which will look something like this. Then we have the x-axis. Then we have the y-axis. And then we have our graph, g of x. So they want that area right there. How can we find that area? Well, it's under the x-axis, so we can do negative integral. Now remember, lower bound to upper bound, right? So negative 2 to 0, right? Lower to upper. Some people might accidentally put 0 to negative 2, but negative 2 to 0, g of x dx. That's the negative integral of negative 2 to 0 for, we can say x plus 3 to the negative 2 minus 2. It's nice to have some indices when working with integration. Now let's see what this is going to become. Now if you're a bit worried about this one here, you can look at the formula sheet, right? The antiderivative is actually going to become negative x plus 3 to the negative 1, and then minus 2x. Going from negative 2 to 0. And so we're going to sub in 0 first, and we're actually going to get negative a third. And then we're going to take away, and then sub in negative 2. So that's actually going to be negative 1 plus 4. Right, that's going to be negative a third minus 3. But because there's a negative at the front, we can distribute that, and we get a third plus 3. This is going to be a third plus 9 over 3. This is actually going to be 10 over 3. So we have 10 over 3 units squared. That's going to be the area. Right, let's go on to the next one. So x is a binomial random variable where x is going to have 4 trials. This is the value of n, and this is the value of p. We need to find the standard deviation of x. Now the variance of a binomial random variable is np times 1 minus p. That's the variance. But remember, the variance is just standard deviation squared. Right, so the standard deviation is just going to be the square root of np times 1 minus p. Now n is 4, p is 9 over 10, times 1 minus 9 over 10. And that's all under the square root. So we get 4 times 9 over 10, and 1 minus 9 over 10 is just 1 over 10. This is going to be square root of 36. 4 times 9 is 36 over 100. That's going to be 6 over 10. That's going to be 3 over 5. So the standard deviation is going to be 3 over 5. Okay, find the probability that x is less than 2. So probability that x is less than 2. Right? Well, if x is less than 2, then we can have x is equal to 1 or x is equal to 0. So probability that x is less than 2 is the probability that x is equal to 0 plus the probability that x is equal to 1. Now the probability that x is equal to 0, you're going to have to look at the binomial distribution formula. That's going to be n choose x. So n here is 4. Choose x. For probability x equals to 0, the x value is actually going to be 0. So 4 choose 0 times the p-value, which is actually 9 over 10, to the power of x, in this case that's 0, times 1 minus 9 over 10, which is actually just 1 over 10, to the power of n minus x. So n is 4, here x is 0, so 4 minus 0 is just 4. We're going to add that and do it on the second one, where the x value is actually going to be 1. So we get n, 4, choose x, 1, times 9 over 10 to the power of 1, times 1 over 10 to the power of 3. Okay, what is 4 choose 0? 4 choose 0 is actually going to be 1. And anything to the power of 0 is also going to be 1. So we get 1 over 10 to the 4. Plus, what's 4 choose 1 going to be? That's going to be 4. And then we get 9 over 10 times 1 over 10 cubed. So this is 1 over 10 to the 4 plus 36 over 10 to the 4. So we get 37 over 10 to the 4. And that's actually going to be this. So therefore, probability x less than 2 is going to be 0.0037. So yeah, there we go. Right, that's what it's going to be. I've put it in decimal form just to make it a little bit easier on the eyes, but that's going to be our answer. Okay, this question was scanned a little bit blurry. Sorry about that. Right? Okay, here we have a function. It's modeling the population of a town after t years. So use the model to predict the population after 4 years. So just find h of 4. That's going to be 3,000 divided by 5, right? Because 4 plus 1. That's 3,000 divided by 5. That's going to be 600. Right, so that's going to be our answer there. All right, a new function h1 is modeling a population where h1 of 0 is h of 0, but h1 decreases at half the rate. Okay, that's important. h1 decreases at half the rate of h at any point in time. State a sequence of 2 transformations that map h to this new model h1. So decreasing, right, talking about decreasing at half the rate, it's going to be to do with the derivative. So first things first, let's find h dash of t. That's going to be quotient rule. That's going to be the bottom function times the derivative of the top function minus the top function times the derivative of the bottom function, all divided by the bottom function squared. So derivative of 3,000 with respect to t is just 0, and derivative of t plus 1 with respect to t is just 1. So we get negative 3,000 over t plus 1 squared. Now, okay, I'm going to let y equal h of t. Sorry, I'm going to let y equal h dash of t. So this is going to go through t comma y. But with this transformation, I want the new one to decrease at half the rate. So I want the new one to go through t comma half y. Right? This is going to be equal to t dash comma half, equal to y dash, right? Equal to t dash comma y dash. So we get t is equal to t dash and half y is equal to y dash. So y is equal to 2y dash. We had y equals h dash of t. So that would mean y is negative 3,000 over t plus 1 squared. And y is going to be 2y dash. And t is just going to be t dash. And so we can move this 2 to the other side by dividing on 2 on both sides. So we get, and if you divide by 2 on both sides, you can cancel out this negative 3,000 and the 2 to get negative 1,500 over t dash plus 1 squared. So the derivative function of h1 is actually going to be this right here. The derivative function of h1 is going to be this, because this is decreasing at half the rate of the original. So how do we find h1? Well, we just have to integrate this, right? And when you integrate this, you can take out the negative 1500. Remember to add the plus c. Now remember, it says h1 of 0 is equal to h of 0. Now h of 0 is 3000 over 1, which is 3000. Right, so h1 of t, so h1 of 0 actually, that's going to be, first let's find h1 of t first properly. Right, so if I expand this, this is going to give me 1500 t plus 1 to the negative 1 plus c. That's 1500 over t plus 1 plus c. Now h1 of 0 is going to be 1500 plus c. But h1 of 0 has to equal h of 0, which was 3000. So c is going to be 3000 minus 1500, that's 1500. Right, so h1 of t is actually going to be 1500 over t plus 1 plus 1500. We're not done with the question yet though. We have to state a sequence of two transformations. So how do we go from h of t to h1 of t? Well, the first thing you can see is there's a dilation by a factor of a half from the t-axis, right? Not the x-axis in this case, t-axis. And then there is a translation of 1500 units in the positive direction of the y-axis. And that's going to be our final answer. Right, so there we go. Maybe I should box that, just because it can be a little bit tricky to see that. Okay, in the town, 100 people were randomly selected and surveyed, with 60 people indicating that they were unhappy with the roads. We have to determine an approximate 95% confidence interval for the proportion of people in the town who are unhappy with the roads. We have to use z equals 2 for this confidence interval. So remember, confidence interval is going to be p hat minus z times p hat 1 minus p hat over n, comma, p hat plus z times p hat times 1 minus p hat over n. So first, let's find z times p hat 1 minus p hat over n. And to do that, we need to find p hat first. That's going to be the number of observations divided by the total number of people sampled. That's going to be 60 over 100, which is 6 over 10, which is 3 over 5. Remember they said use z equals 2. So we get 2 times square root of 3 over 5 times 1 minus 3 over 5 over n. And in this case, n is the number of people sampled, so that's going to be 100. So this is going to be 3 over 5 times 2 over 5, all divided by 100. That's going to be 6 on 25 on 100. 2 times the square root of 6 on 25 on 100. That's going to be 2 times the square root of 6 over 25 times 100. And we're not going to actually calculate 25 times 100 just yet. We'll see why in a second. So this actually becomes 2 times root 6 over root 25 times 100. That's the same as 2 root 6 over root 25 times root 100. And that is 2 root 6 over 5 times 10. That is 2 root 6 over 50. That is root 6 on 25. Right, so our confidence interval is going to be p hat, which is 3 over 5, minus that z square root p hat thing, which is root 6 on 25, comma, 3 on 5, plus root 6 on 25. Right, that's going to be our final answer for this one. Okay, a new sample of n people results in the same sample proportion. Okay, we have the same sample proportion. Find the smallest value of n to achieve a standard deviation of root 2 on 50 for the sample proportion. So the standard deviation of a sample proportion, the standard deviation of sample proportion p hat, is actually square root of p hat 1 minus p hat over n. Now we know p hat because they say the value of p hat doesn't change. So it's going to be 3 over 5 times 1 minus 3 over 5. All divided by n because they're taking a new n, right? It's not going to be 100 anymore. So this is going to be 3 on 5 times 2 on 5 all over n. That's going to be 6 on 25 on n. That's going to be root 6 on 25n. And that's actually going to be root 6 on root 25 times root n, which is root 6 on 5 times root n. This is the standard deviation. And we want this to be root 2 over 50. So cross multiplying, we're going to get 5 root n, root 2 equals 50 root 6. Now dividing by 5 on both sides, we get root n root 2 is equal to 10 root 6. And now we can divide by root 2 on both sides, so we get root n is equal to 10 root 6 on root 2. We can square both sides, we get n is equal to 10 root 6 on root 2 squared. That's going to be 10 squared times root 6 squared over root 2 squared. That's going to be 100 times 6 over 2. That's going to be 300. So therefore, n is going to be 300. Okay, on to the 4 marker. And this one is pretty tricky. I'm not sure why this is in an exam 1, because it seems like a bit of overkill. But anyway, let's start with this. The first thing we'll realize is that you can actually bring up this 2 and put it to the power. Right, so log base 3 of x minus 4 squared plus log base 3 of x is equal to 2. Now when you're adding 2 logs of the same base, that's actually just going to be a log with the same base and whatever was inside them multiplied. Now we're going to get this 3 to the power of 2, which is 9. That's going to be equal to whatever's on the inside. So that's going to be x times x squared minus, so a minus b squared is a squared minus 2ab plus b squared. So minus 8x plus 16 is equal to 9. So x cubed minus 8x squared plus 16x. And then you can take the 9 to the other side, so we get minus 9 is equal to 0. So how can we solve this cubic right here? Well, you can use remainder theorem, right? So let's try plugging in 0. If you plug in 0, you get negative 9. That's not going to work, right? For remainder theorem, it has to equal 0. Let's try 1. Let's try x equals to 1. So we get 1 cubed minus 8 times 1 squared plus 16 times 1 minus 9. That's going to be 1 minus 8 plus 16 minus 9. That's going to be minus 7 minus 9 plus 16. That's actually minus 16 plus 16. That's 0. Okay, what does this actually tell us by plugging in 1 and it's equaling 0? What is this actually telling us? This is telling us that x minus 1 is a factor of x cubed minus 8x squared plus 16x minus 9. Now we're going to have to do something that probably haven't done in a while, right? That's going to be polynomial division. So we're going to get x cubed minus 8x squared plus 16x minus 9 divided by x minus 1. And because it's a factor, the remainder should be coming out to be 0. So the first term here is going to be x squared. Now x times x squared is x cubed like we want it. And then minus 1 times x squared is minus x squared. We can do subtraction. X cubed minus x cubed is 0. Minus 8x squared minus negative x squared. That's actually going to be negative 7x squared. Right, so we get negative 7x squared. And of course, we can bring down the 16x from up there as well. So the next term is going to be minus 7x. This is going to multiply with that to give minus 7x squared, like we want it. And then negative 1 times negative 7x is just positive 7x. Doing subtraction, we get 0. And then we get 9. Right, we get 9x. To get 9x, we can bring down the minus 9. And the final term is going to be plus 9. And so 9 times x is 9x. Minus 1 times 9 is negative 9. Taking away those two, we just get 0. So what does this mean? Well, this means that what we got right here, this quadratic, times this factor right here, is equal to our original function. So x squared minus 7x plus 9 times x minus 1 is our original function, which was equal to 0. Right? It was equal to 0. So using null factor law, we're getting x squared minus 7x plus 9 is equal to 0, or x is equal to 1. Now let's quickly check x is equal to 1 and see if it actually works, right? Because sometimes we can get solutions in these logs that actually don't work. If I substitute x is equal to 1, we're going to get 2 log base 3 of 1 minus 4 plus log base 3 of 1. That's 2 log base 3 of negative 3. Okay, there's the issue straight away, right? You can't have a negative number inside a log. So x equals 1 actually does not work, right? You're getting it as a solution, but once you plug it back in, it actually does not work. It breaks the equation because you're getting a negative number inside a log. So I'm just going to put a little orange thing here, reminding us that we're not going to be continuing with that. We're going to be rejecting that later on. Okay, now we have x squared minus 7x plus 9 is equal to 0. And you'll notice here that you actually can't find some nice numbers to factorize this. We have to complete the square again on this and then solve it. And that's actually why I said this question was a bit of overkill, because you can see the working out starts to get a bit too much. But anyway, let's try to solve this in turning point form. Right, first we need to find the derivative, which is 2x minus 7. Set that equal to 0. X is equal to 7 over 2. Plugging that back in, we get 7 over 2 squared minus 7 times 7 over 2 plus 9. That's 49 over 4 minus 49 over 2 plus 9. That's actually going to be minus 49 over 4 plus 9. That's going to be minus 49 over 4 plus 36 over 4. Right? That's going to be negative 13 over 4. So our quadratic can become x minus 7 over 2 squared minus 13 over 4. And we want that quadratic to equal 0. So now let's try to solve this, right? This is getting a bit hectic. X minus 7 over 2 squared is equal to 13 over 4. X minus 7 over 2 is equal to plus or minus root 13 over root 4. But root 4 is just 2. And so we get x is equal to 7 on 2 plus or minus root 13 on 2. That's actually just 7 plus or minus root 13 all divided by 2 because they have the same base. Okay, but hold on. How do we know that all of these work, right? How do we know that both these work? Because one of them might break the equation, right? See, look at this. There's a log base 3 of x minus 4. Anything inside a log has to be greater than 0. So x minus 4 has to be greater than 0. So x has to be greater than 4. And of course, there's the other one as well. There's a log base 3 of x. So anything inside a log has to be greater than 0. So x has to be greater than 0. But you can see that if x is greater than 4, then x is already greater than 0. So we don't need to worry about the restriction on this one too much. But the main thing is that x has to be greater than 4. Now, let's think about root 13, which is what we have. Now, root 13 is between root 9 and root 16. That means that root 13 is between 3 and 4. Right? Now, let's add 7 to that. So we get 10. And then we get 7 plus root 13 and 11. Now let's divide everything by 2. So we get 5, 7 plus root 13 on 2, 11 on 2. Okay, so this one, 7 plus root 13 on 2, is going to be between 5 and 11 over 2, right? That is satisfying the condition of being greater than 4. So this is checking out. Let's try the other one. Right, so once again, we know that root 13 is between 3 and 4. Minus root 13 is going to be between minus 4 and minus 3. Adding 7, we're actually going to get 3. Four. Okay, and then dividing by 2, we're going to get this. So 7 minus root 13 on 2 is between 1.5 and 2. That is clearly less than 4, right? So that's not satisfying our condition. So we can actually reject x is equal to 1, and let's just double check it was x is equal to 1. Yep. So reject x is equal to 1, and x is equal to 7 minus root 13 on 2, as x has to be greater than 4. So therefore, after all that, for 4 marks, right, x has to be equal to 7 plus root 13 on 2. Boom. Okay, let's go to the next one. So we're nearing the end now. So part of the graph of f on a domain negative pi to pi for x sine of x is shown below. Use the trapezium rule with a step size of pi on 3 to determine an approximation of the total area of the graph of y equals f of x and the x-axis over the interval 0 to pi. Okay, a lot of fancy stuff, but all they're saying is we just have to use trapeziums, right? We just have to use trapeziums to approximate the area under the curve. And we're going to have a step size of pi on 3. So we're going by pi on 3 each time, right? So that means we're actually going to have 3 trapeziums. And if you remember, the very first starting point is x0, then the next one is x1, then x2, then x3. Because our step size is pi on 3, right, x0 is going to be 0, because that's our starting point. And then the step size of pi on 3 we get here, that's going to be x1, then x2, then x3. Now the formula goes something like this. So xn minus x0 over 2n times f of x0 plus 2 times f of x1 plus 2 times f of x2 And you're going to keep doing that until you get to xn. So the very first one, f of x naught, and the very last one, f of xn, you're going to add normally without multiplying by 2. So let's see this. xn is the last one, which is x3, which is actually pi, minus x naught, which is 0, over 2 times n. N is the number of trapeziums. In this case, that's 3. So 2 times 3 is 6. Okay, f of x naught. X naught is 0, so f of 0. You can see that's just 0 times sine of 0. That is 0. Okay, plus 2 times f of x1. And x1 is pi on 3. So we get 2 times pi on 3 times sine of pi on 3. Right? F of pi on 3 is going to be this right here. And you just want to multiply that by 2. So you get 2 pi on 3 times sine of pi on 3. And sine of pi on 3 is actually root 3 on 2. So you get pi root 3 on 6. Okay, next one. x2 is 2 pi on 3. So we're going to get 2 times 2 pi on 3 times sine of 2 pi on 3. Right? So we're going to get 4 pi on 3 times, and now sine of 2 pi on 3 is also root 3 on 2. So we're going to get 2 pi root 3 on 3. And now we get to the last one, x3, which we're going to add normally. So just f of x3, and x3 is pi. So we get pi times sine of pi. Now sine of pi is 0, so pi times 0, that's going to be 0. So we're getting pi on 6 times pi root 3 on 6 plus 2 pi root 3 on 3. That's pi on 6 times pi root 3 on 6 plus 4 pi root 3 on 6. And that's going to go to 5 pi root 3 on 6. Right? That's going to be 5 pi squared root 3. I feel like something's off there. Right, so let's just make sure we did everything correctly. So 2 times pi on 3 times sine of pi on 3, 2 pi on 3 times root 3 on 2. That's pi root 3. Ah, that's pi root 3 on 3. Okay, there we go. Sorry about that, guys. So that's pi root 3 on 3. Because these 2's would cancel. Right, let's make sure this one is also correct. Okay, so that's going to be pi root 3 on 3. So let's get rid of all this. So we're going to get pi root 3 on 3 plus 2 pi root 3 on 3. That's going to be 3 pi root 3 on 3. That's going to be pi root 3. Okay, so we're getting pi squared root 3 on 6. So the area is approximately pi squared root 3 on 6 units squared. Find f dash of x. Okay. Right? This is just going to be product rule because you have two functions being multiplied. It's going to be the first one times the derivative of the second one. So the derivative of sine of x is actually cos of x. And then we're going to have plus the second function, sine of x, times the derivative of the first function. And the derivative of x is just 1. So we have x cos x plus sine of x. Okay, determine the range of f dash of x over the interval pi on 2 to 2 pi on 3. Okay, So you can see pi on 2 would probably be somewhere around here. Right, we look at the gradient at pi on 2. Right, so we should have some sort of positive gradient at pi on 2. And then you'll see as we go to 2 pi on 3, it's becoming less and less until it's going to almost 0, basically. Now, it doesn't have to be exactly 0. From the graph, it looks like there's a turning point at 2 pi on 3, but of course, you can't really be sure of that. Right, so it could just be slightly negative like that. Okay. So let's find what f dash of pi on 2 is. So we're going to use this right here. That's going to be pi on 2. So let's go down here and do it actually. F dash of pi on 2. That's going to be pi on 2 times cos of pi on 2 plus sine of pi on 2. Now cos of pi on 2 is 0, so that's just 0. And sine of pi on 2 is 1, so this is 1. Okay, so the gradient at x is equal to pi on 2 is actually 1. Now let's find the gradient at 2 pi on 3. That's going to be 2 pi on 3 times cos of 2 pi on 3 plus sine of 2 pi on 3. That's going to be 2 pi on 3. Now cos of 2 pi on 3, that's actually going to be negative a half. And sine of 2 pi on 3 is going to be root 3 on 2. So we get negative pi on 3 plus root 3 on 2. And so you can see the gradient is going from 1, and then it's going all the way to this value right here, which is actually going to be negative. Right, so that's going to be negative. So the range of the derivative, right? Remember the derivative, the range when we say it, it goes from the lowest to the highest. So the lowest is minus pi on 3 plus root 3 on 2. And it's going all the way to 1. Hence, verify that f of x has a stationary point for x in the element of pi on 2 to 2 pi on 3. Okay. Well, we can see the range is going from some negative number. So first off, negative pi on 3 plus root 3 on 2 is less than 0. Right? That's less than 0. So it's going from some negative number all the way to 1. That means f dash of x, so we think about it, f dash of x might look something like this. Right? It's going from some negative number to 1. That's its range. That means there must be an x equals a right here such that f dash of a is equal to 0, right? Because if its range is from some negative number to 1, it has to have an x-intercept. So there has to be an x is equal to a that we don't know, such that f dash of a is equal to 0, because the range of f dash of x is negative pi on 3 plus root 3 on 2 to 1. So therefore, f of x will have a stationary point in the interval. Right, so just using some reasoning there, and you actually have to use your answer from the previous question here. I know some people are going to try to solve f dash of x is equal to 0, and you're going to run into some trouble because x cos of x plus sine of x is equal to 0. We can't solve that in methods, right? That's outside the study design. So I know people are going to try to solve f dash of x is equal to 0 to prove that it has a stationary point, but that's going to prove to be pretty difficult, right? So you have to use your answer from the previous question. That's why it says hence. Okay, on the set of axes below, sketch the graph of y equals f dash of x on the domain negative pi to pi, labeling the endpoints with their coordinates. Okay. And you may use the fact that the graph of y equals f dash of x has a local minimum at approximately negative 1.1, comma negative 1.4. Okay, so somewhere around here, maybe a little bit further down, maybe somewhere around here, right? And a local maximum at approximately 1.1, comma 1.4. So approximately here, right? And we have to find the endpoints. Remember, a function is not differentiable at the endpoints, right? So the derivative at the very end should be an open circle. Even though they've said domain is including, which seems a bit silly, but, you know, we're going to stick with it. We're going to say functions are not differentiable at the endpoints, as we know. So the endpoints here for the derivative function should be open. So first, let's find the derivative at the endpoints. So f dash of pi, that's going to be pi times cos of pi plus sine of pi. Now cos of pi is negative 1 and sine of pi is 0. So this is negative pi. So it should be pi comma negative pi. So somewhere around here. So that pi comma negative pi. And I've done an open circle. Let's find f dash of negative pi. That's the other endpoint, right? Somewhere here. That's going to be negative pi times cos of negative pi plus sine of negative pi. Now cos of negative pi is also negative 1. And sine of negative pi is also 0. So we're going to get just pi. So it's going to be somewhere up here. Right? Around there. So negative pi, comma pi. So now if we try to connect the dots, right, we're probably going to get something like this. And you can see that a stationary point on f of x is somewhere very close to x is equal to 2, right? So our derivative graph is having an x-intercept somewhere around 2. And the same thing with negative 2, right? Maybe try to get this a little bit closer to negative 2, right? But this should be the general shape. And our derivative graph has to pass through the origin because you can see there's clearly a turning point right at the origin, right? So this is what it should look like approximately. And remember to do open circle at the endpoints because functions are not differentiable at their endpoints. Okay, coming on to the last page, we have this function g of x, which is the cube root of x minus k plus m. K can be any real number except 0, and m can be any real number. Let the point P be the y-intercept of y equals g of x. Find the coordinates of P in terms of k and m. Okay, first of all, I'm going to rewrite g of x as this, right? This is the same thing. A third is the same as the cube root. So P is just the y-intercept. So we need to find g of 0. That's negative k to the third plus m. So P is going to be negative k to the third. Sorry, it's going to be 0, comma, negative k to the third plus m. Right? Because that's just the y-intercept. Find the gradient at P in terms of k. Okay, so we need to find g dash of x. Have to use a little bit of chain rule here, but it's not really too bad. So you get a third times x minus k to the power of a third minus 1. And of course the plus m is going to disappear in the derivative because that's just basically a number, right? And you have to do times the derivative of the inside. But the derivative of the inside in this case is just a 1. So it works out pretty nicely. So you get a third x minus k to the power of negative 2 over 3. Now to find the gradient at P, right? At P, the x-coordinate is 0, so g dash of 0 is going to be a third times negative k to the negative 2 over 3. So that's going to be our answer. Given that the graph of y equals g of x passes through the origin, express k in terms of m. Okay, so if it passes through the origin, we know that g of 0 has to equal 0. Now g of 0 is negative k to the third plus m, and this has to equal 0. So negative k to the third has to equal negative m. We can cube both sides, so you get negative k is equal to negative m cubed. Now negative m cubed is negative m times negative m times negative m. That's just negative m cubed. So k is going to equal m cubed. Right, there's our answer for this one. Okay, on to the last one. Let the point Q be a different point from the point P. Okay, so P is a different point from Q. So let's say P has coordinates A, comma G of A. Right? We don't know A yet, but we can try to find it later on. Such that the gradients of G, such that the gradient of G at points P and Q are equal. Okay, so G dash and the x coordinate at P is 0. So the gradient at 0 has to be the same as the gradient at P. And the P has an x coordinate of A. So G dash of 0 has to equal G dash of A. Given that the graph of y equals g of x passes through the origin, okay, if it passes through the origin, we know that k is equal to m cubed. Find the coordinates of q in terms of m only. So no k, only m. Okay, g dash of 0 was a third, negative k to the negative 2 over 3. And remember, g dash of x was this right here. So I can copy this and put this here. But we're doing g dash of a, so instead of x, we can replace that with an a. If I can just get rid of that, sorry. Okay, here we go. Now we have to try to solve for a. But first, we know that k is equal to m cubed. So let's replace all the k's with an m cubed. Right? So the first thing you'll see that we can do is we can multiply by 3 on both sides to get rid of the third. The next thing we can do is we can actually raise both sides to the power of 3 to get rid of this, a third part right here. So we're going to get this. And next we can raise both sides to the power of negative 1 to get rid of this negative sign right here. Right, so here we go. Now, this is going to be m to the power of 6 equals a squared minus 2am cubed plus m to the 6. Right, just expanding the right-hand side. And you can see if I move the m to the 6 here, then that will cancel out with this one to give a squared minus 2am cubed is equal to 0. Factor out an a, we get a minus 2m cubed is equal to 0. Using null factor law, a is equal to 0, or a minus 2m cubed is equal to 0, so a is equal to 2m cubed. Now, we are going to have to reject a is equal to 0. And the reason is because if a becomes 0, then then this should be actually q, sorry about that. If a becomes 0, then q is just becoming the same as p, right? Just the y-intercept. So reject a equals 0 as P and Q must be different. Okay, A is equal to 2m cubed. So let's find g of 2m cubed. Now we know that g of x is x minus k, but we know that k is actually just m cubed in this case, right? To the power of a third plus m. So g of 2m cubed, that's going to be 2m cubed minus m cubed to the power of a third plus m. That's just going to be m cubed to the power of a third plus m. Now m cubed to the power of a third, that's just m, so you get 2m. So therefore q is going to have x coordinate of 2m cubed and a y coordinate of 2m. So there we go. That's going to be the entire exam. I think there's definitely some tricky questions on there, some really tricky ones, right? Sketching derivative, trig graphs, and all this stuff. But yeah, this is, and once again, this is not endorsed by any way from VCAA, right? I don't have any inside information or anything like that. These are just my suggested solutions. So please let me know if I made any mistakes. And yeah, I hope everyone did well. And I wish everyone the best of luck for tomorrow's exam. And yeah, I hope this is able to help. Thanks.